Yes, sir. Please go to full mode in slide first and let's start.
Uh, Hello everyone, welcome to the iitians gate classes. In today's session, we will solve the GATE 2022 paper of Mechanical Engineering Set 1, focusing on the engineering mechanics and theory of machines questions. There were total 12 mark questions asked in this, 6 for 2 marks and 3 questions were asked for 1 mark. Let's solve them one by one. Coming to the first question, this is from the theory of machine governors topic. The figure shows a schematic of simple watt governor mechanism with the spindle O1, O2 at an angular velocity omega about the vertical axis. The balls at P and S points are having equal masses. Assume that there is no friction anywhere and all other components are massless and rigid. The vertical distance between the horizontal plane of rotation, which is this, and of the balls, and the pivot O1 is denoted by the height, which is h, height of the governor, and the value of h is equal to 400 millimeter at certain omega. If omega is doubled, the value of h will be. So as we know, this is the governor. Whenever we increase the speed of the governor, the more centrifugal force will get created, because we know centrifugal force is mr omega square. As we increase the omega, the centrifugal force will increase. These balls will tend to move away from each other, and ultimately the value of h will reduce. So of course we have 400, it will reduce by 400. It will reduce from it. It will not increase. All the options are below it, so we have to look into the exact value. So basically, we know that the relationship between height of the governor and the speed is h is equal to 895,000 divided by n square millimeter. So basically, height is inversely proportional to this RPM square. So, and we know RPM and omega are proportional. So we can say that for 400 height, if speed is omega square, then for 2 omega speed, what will be the height? Let's say it as x. So we can say that 400 is equal to 4 omega square divided by omega square divided by x. Omega square will it cancel, and x will be equal to 400 by 4, which is 100. Okay, so in this case, the correct answer is 100 mm. So option B is correct in this case. Okay, coming towards the next question. The plane of figure represents a horizontal plane. A thin rigid rod rest is basically it is pivoted at point O without friction about the vertical axis passing through O. Its mass moment of inertia is given. The value of I is known to us, 0.1 kg centimeter square about this point. A point of mass 0.001 kg, this is the one, hits this basically rigid rod, and it is coming with a velocity of 200 centimeters per second, which is at a location 10 centimeter from the point O, and basically it sticks to it. Immediately after the impact, the angular velocity of the rod is what they are asking us. So we can clearly see this is an example, or this is problem from the mechanics topic, where specifically the dynamics part, and in that this problem can be solved by using the law of conservation of momentum. Momentum before impact and after impact will remain same, because we can clearly see the rod and this rod is stationary. We have this uh, rigid ball which is hitting that rod, and this ball is also ball is having some initial velocity, and after impact both rod and ball will move with a certain velocity, and that is what they are asking us. So I would say that the momentum of the rod will be IR omega r plus momentum of the mass which is hitting the rod is Im omega m. Out of this part is zero, because omega of rod is zero, as we know that the rod is not um, moving, it is stationary. Now this has to be equal to IR plus I omega. So we have a combined moment now. The moment of inertia will be part of like a combined moment of inertia we have to calculate, because the the ball is sticking the rod. So we can say um, it will be IR plus IM into omega R dash, and this omega R dash is what we are supposed to calculate. IM is known to us, that is mr square. Mass of the that ball is 0.001 into, it is hitting at the radius 10, so it's a 10 a square. Okay, and omega m, it is with a velocity of 200. V is equal to r omega, so omega is equal to v by r, so 200 by 10. It will create omega of 200 by 10. Coming towards the right hand side part, we have IR, which is already given to us 0.1. IM, we have just calculated 0.001 into 10 a square. Okay, so it's like mr square basically, and into omega r dash. So if we solve this omega r dash, we can calculate, and it will come around 10 radian per second. So the answer for this is 10 radian per second. We don't have an option here, you have to type it. So the 10 is the correct answer in this case, because they are asking us in radians per second. Okay, any doubt in this? Moving towards the next, we have a rigid uniform annular disk, which is pivoted at point A here as shown in the figure, in a uniform gravitational field as shown, such that it can execute small amplitude simple harmonic motion. Okay, so it can execute a small amplitude simple harmonic motion in the plane of the figure without slip at the pivot point. The inner radius is small r and the outer radius is capital R. The relationship between the inner and outer radius is also given, that is r square is equal to capital R square by 2, and the acceleration due to gravity is small g. If the time period of the small amplitude simple harmonic motion is given by t is equal to beta times pi under root capital R by g, where pi is the ratio of circumference to the diameter of the circle, then the beta is given by, and they're asking us to round off it to 2 decimal places. However, they have not given us the options, so we are supposed to type the answer in this case. Coming towards the solution part of it, imagine, let's say, if we rotate this annular disk by some angle theta. Okay, so look at this. This is initially pivoted here, and then let's say if we rotate by some certain angle theta. Okay. With theta angle, we are rotating it. How the structure will look like? Let's say by theta angle, we are rotating it about the pivot, of course, about the pivot. How the structure will look like? Let me show you roughly. Right. So if I rotate it through omega in this direction, somewhere here you will have now pivot. Okay, because pivot will not be exactly at center, right? Center will be somewhere here, and the pivot will be here, right? Because you can clearly see we are rotating in this direction. Pivot will not change the direction because there is a fixed point. Um, However, our annular disk will be moving so about the pivotal position. So this is how the actual situation will look like. If we are moving in this direction, so as to let's say this is the mg force is acting in downward direction, and this is if it, let's say somewhere here it is mg. Okay. We know that according to the D'Alembert's principle, if we want to apply the equations of equilibrium, so basically if we consider a body is in dynamic equilibrium, then we have to apply the inertial force in the direction opposite to the motion. So we can say that this is I theta double dot should be here, which is in the opposite direction to the motion. So let me correct it. This is theta, not omega. Theta is in this direction. I theta double dot is in the opposite direction. And this mg, you can clearly see mg will also create a clockwise moment. And I will write here mg, and the component will be r sine theta. Okay, because we are um, rotating it by theta angle, and which is, yeah, from the pivot it is distance r. So sine component of r is what will be the perpendicular distance. So mg r sine theta is the clockwise moment. So now the equation of equilibrium, if I say, is I theta double dot in clockwise direction plus mgr sine theta again in the clockwise direction has to be 0. Let me write it. I about a, okay, not about the origin, I about a, because about the pivotal point we are talking about, I about a theta double dot plus mg r sine of theta equal to 0. For small theta angles, sine of theta is equal to theta. So we can say that ia theta double dot plus mg r theta equal to 0. We know that 3 by 4 mr square is the moment of inertia of this disk about the center, but we don't know about ia. According to the parallel axis theorem, okay, according to the parallel axis theorem, we can say that ia is equal to ig plus mr square. Ig is what? 3 by 4 mr square. Okay, capital R square, and yeah, we know that small r square is equal to capital R square by 2. So using that, I can say mr square will be half of m capital R square. So it will be total 5 by 4 mr square will be ia, that is moment of inertia about the point A, that is the pivotal point. So now this equation can be simplified as pi by 4 mr square theta double dot plus mg, r can be written as r by root 2 theta equal to 0. So from this, we can calculate, cancel out the value, rr value, and we can say that theta double dot is equal to 4g divided by 5 root 2 r theta. Okay, theta double dot plus 4g by 5 root 2 r, theta equal to 0. Okay, omega n square is the natural frequency, that is 4g divided by 5 root 2 r. Okay, so omega n will be 2 divided by under root of 5 root 2 under root of g by r. Okay, this is your omega n, and time period we know 2 pi by omega, which is can be written as 2 pi by omega is what? Again, this 2, this under root of 5 root 2 will go up, under root of g by, sorry, under root of r by g will come, right? And they have also given in the question that time period is this beta pi under root of r by g. Beta pi under root of r by g. So r by g gets cancelled, pi gets cancelled, 2 will get cancelled. So beta will be equal to under root of 5 under root 2. And if you calculate, this will be approximately 2.66, because they are asking us to write up to the 2 decimal places. Hence, the answer is 2.66. I hope it is clear. Okay, coming towards the next question. This is from the theory of machines, mechanisms and machines chapter, first chapter of the subject. Yeah, let's see what it says. Planar 4-bar linkage mechanism with 3 revolute kinematic pairs. So this is completely revolutic pair, this is also revolute pair, and this is also revolute pair, and one prismatic kinematic pair. This is the one we are talking about, is shown in the figure. AB is perpendicular to the CE, and FD is perpendicular to CE, and the T-shaped link, okay, CDEF is constructed such that the slider B can cross the point D. Okay, it can cross this point D, and CE is sufficiently long. Okay, this is very long, sufficiently long. For a given length, as shown in the figure, the mechanism is. They have given some options. Okay, so they are talking about what kind of the mechanism is this, whether it's a double crank, um, uh, or let's say Grashof, non-Grashof, or so on. Okay, so basically it's a Grashof chain or it's a non-Grashof chain. These are the kinds of options we have. Okay, so let's talk about first what Grashof law says. Okay, what Grashof law says. Write down Grashof's law. Grashof law states that in a 4-bar chain mechanism, there will be at least one revolving link if length of shortest plus longest link is less than equal to the sum of the other two. So P and Q are the other two, and S and L are the shortest and the longest. In this particular case, we can see that this is like a what we can say is a we have this link. GF is the link. We can call it as a fixed link having let's call this as a link number 1. Okay, this is a link number 1, which is a fixed link. This is a 3 centimeter. We have another link which is 5 centimeter, link number 2, GA. However, the link 3 is not just 3 centimeter. It is, we can say it's a link 3 is 3 plus LX. Okay, because it is a sliding pair. Sliding pair is what? Sliding pair is a turning pair with an infinite radius, right? Sliding pair is nothing but the case of a turning pair with an infinite radius. So the effective length is not just 3 centimeter for the link, third link. It will be 3 plus Lx. Okay. I will show you the effective diagram of it, and the FD will be 1.5 plus Lx. Okay, because basically these two lines, okay, these two lines are parallel and will meet at infinity. We don't know where to form a pair, right? And that's why their lengths are high enough. So the largest length I would consider as a 3 plus Lx, and the shortest length I will consider as a 3 centimeter in this case. Okay. So in this case, I'll rewrite the stuff again. Link 1 is 3 centimeter, and that is the shortest one. That is link GF. Link number 2 is 5 centimeter, which is GA. Link number 3 is uh, A to B, you can say, means or let's say towards the pair where they meet. So I would say link number 3 just, okay, that is 3 centimeter plus Lx, and this is the largest length, I would say, because Lx is almost infinity, and link number 4 is 1.5 plus Lx, so it is in between. Okay. So this is not largest, this is not shortest. What is the shortest link? 3 centimeter. What is the largest link? 3 plus Lx. Whether it's less than, what is the PP is, the other two is 5 plus 1.5 plus Lx. Okay. So Lx gets cancelled. 6 is less than equal to 6.5. Yes, it satisfies the condition. Hence, we can say that the current mechanism satisfies the law of Grashopp's law, and it is a class 1 mechanism. So it will have at least one revolving pair. But it even Grashopp law says if you fix the shortest link, you will end up with a double crank mechanism. Okay. If it satisfies the Grashopp law and shortest link is fixed, then you will end up with a crank mechanism. Okay, you can also call it as a double crank mechanism. And hence, in this case, option A is correct, that a Grashopp chain with the links AG and okay, AB and CDF completely rotable about the ground link FG. Okay, so hence option A is correct in this case. Okay, it's not, the other options are incorrect. Okay, the second option says it's not a Grashopp, so it's wrong. Third option says we have one oscillatory and one rotatory, and hence, yeah, the other option says the border of Grashopp and non-Grashopp, so which is also incorrect. Option A is correct in this case. Coming towards the next question, this question is from the vibrations topic. Let's see what it says. Consider a force single degree of freedom system governed by x double dot of t plus 2 tau or 2 tau omega n x dot of t plus omega n square x of t is equal to omega n square cos of omega t, where zeta and omega n are damping ratio. Sorry, this is zeta, not tau. Zeta and omega n are the damping ratio and undamped natural frequency of the system, respectively. While omega is a forcing frequency, the amplitude of the force steady state response of the system is given by this. Okay, 1 minus r square bracket square plus 2 zeta r square raised to the power minus 1 by 2, where r is the ratio of omega by omega n. The peak amplitude of this response at the frequency omega is equal to omega p. If omega d denotes the damped natural frequency of the system, then which of the following equation option is true? Okay, so omega d is the damped natural frequency, omega n is the natural frequency, and omega p is like the corresponding to the peak amplitude. So we have to define a relationship between the omega n, omega d, and omega p. Let's try to solve this question. Amplitude of the vibration is they are already given, right? That is 1 minus. Okay, let's take it as it is then. X is equal to 1 minus r square bracket a square plus 2 zeta r 2 zeta r whole square raised to the power 1 by 2. Okay, so yeah, let's say raised to the power 1 by 2. We know that you might have studied in the mathematics that if you want to maximize or minimize a certain function, you differentiate it and equal to 0, equal to 0. So this entire function will be minimum if you can just ignore this part, raised to the power 1 by 2. X square will be minimum when, sorry, under root of x square plus 2 will be minimum when x square plus 2 will be minimum, right? So the under root doesn't make sense in the minimization or the maximization problem. So I would say that I'll consider it as x is equal to 1 minus r square plus 2r 2 zeta r whole square. I would say if this is minimum, then this will also be minimum. Differentiating without root is easier than differentiating the function with under root. So that's why at this point we will differentiate this x with respect to r and equate it to 0. So it is 2 into 1 minus r square into minus of 2r plus 2 zeta bracket square as it is, and differentiation of r square is 2r equal to 0. This 2r, this minus 2r gets cancelled. 2 times 1 minus r square is equal to 2 zeta square. If you solve this, r can be written as under root of 1 minus 2 zeta square. R is what? That is omega p by omega n. Okay, that is what they have mentioned. This implies omega p we know as under root of 1 minus 2 zeta square omega n. We also know damped natural frequency is 1 upon, sorry, under root of 1 minus zeta square omega n. So you can clearly see here that you can compare these two. A minute. We can clearly indicate here that this is yeah, this is omega n. Now we can clearly see that omega n is always greater. Okay, so from comparing these two relation, we can say that omega n, because omega d is what? Omega n into under root of 1 minus zeta square. Zeta square will be, zeta is less than 1. So if you subtract it from 1, of course the number will be less than 1. So omega n is always bigger. So omega n is greater than. Then talking about the omega d and omega p, of course omega d will be bigger, because in omega p calculation we are multiplying 1 minus 2 zeta square. So here I would say omega d, omega p. Okay, n, d, and p. So option A is correct in this case. Okay, it's very simple. We are we already know the relationship between omega d and omega n. That is damp natural frequency, how it is related to the natural frequency. And from this given data of the amplitude, we have derived a relationship between the natural frequency versus the um, omega p, that is the frequency at the peak. And final conclusion which we are making is the natural frequency is greater than damp frequency is greater than the frequency at the peak amplitude. Coming toward the next part, this is from the stresses topic. Let's see what it says. A structure along with loads applied on it is shown in the figure. Self weight of all the members is negligible and the pin joints are frictionless. AE is a single member that contains pin C. A is a single member that contains pin C. Likewise, BE is a single link where that contains D point. Members GI, I is here, member GI, and FH. Yep, this is are overlapping rigid members. They are overlapping rigid member. The magnitude of the force carried by the member CI is. So we are supposed to calculate force in the member CI. We can clearly know where we know that whenever this kind of bigger stress structure is there, always we have to solve the problem by the method of sections, because we cannot use method of joint in this case since it is a complex stress structure or the bigger stress structure. So what we would do is like we will basically pass a section like this, passing from three members and passing from the member in which force is desired to be calculated. And we have to draw the free body diagram of either side. In this case, we already know the forces on the right hand side. We will prefer to draw the free body diagram of the right hand side. So how it will look like in short is I'll show here. Okay, so you have 4 kilonewton in a downward direction, 2 kilonewton in the rightward direction. Then we have okay, let's write now the names first. This point is I, this point is H, this is E, this is F, and this is G. This is 3, this is also 3 meters. Here we have one horizontal force, that is EFD, this FDE. We have one force here, FEC. Okay, let's call it as ED, and this is FIC. Okay, so this is the free body diagram. Height, what is the height? Let me calculate it. In this case, let's assume this as a triangle. These are two, let's say, similar triangles. So this is 2 centimeter, this is 2 centimeter. So the height of this right angle triangle is the this bigger right angle triangle A, B, and E is 4 meter, and the base is 3 meter. And the other similar triangle to it, it is CD and E, whose height is 2. However, we don't know the base, so base has to be CD. So CD will be equal to how much? 1.5. Okay, so this height is 1.5. Is what we have calculated from by using similar triangles. Now let's use it here. Okay, let's take the moments about point E because this is unknown. So if we take the moments about point E, the moment because of the force EC and force ED will be 0 since they are passing through this point, and only one unknown will be there, FIC, which will help us to get it. So the moment created about point E in equating to 0 is like 4 kilonewton at point G creates 4 into 6 clockwise moment. 2 kilonewton at point H creates 2 into 1.5 clockwise moment, and minus FIC at point I creates a counterclockwise moment like this equal to 0. So FIC can be calculated as 24 plus 3 divided by 1.5. So that is 27 divided by 1.5, which is 18, approximately 18 kilonewton. So in this case, they have not given us the um, option. Yeah, they are asking us to write it. So 18, because they are asking us the integer, 18 is the correct answer in this case. Coming towards the next question. Two rigid rods. Okay, this is from the mechanics again. Two rigid massless rods, PR and QR, are joined at a frictionless pin joint R. Okay, and they are resting on the ground. Okay, this P and Q are on the ground respectively, as shown in the figure. The vertical force F acts on the pin. Okay, here as shown in this figure. When the included angle is less than 90 degrees, the rod remains in the static equilibrium due to Coulomb's friction between the rods and the ground. However, at the theta is equal to 90 degree, okay, impending the slip occurs simultaneously at both the points P and Q. Then the ratio of coefficient of friction at Q to the coefficient of friction at P is, so mu Q by mu P is what they are asking us. Okay, so let's starting with the free body diagram. Assume that now we have a 90-degree angle and slip is started to occur. Okay, this is a 90-degree angle. Let's call this as a theta 1 and this as a theta 2. This is a 5 meter. This is a 12 meter. They have already given to us. And the force F is applied here. Let's try to draw the free body diagram for point P and point Q. This point is R. Okay, so at point P, we can say that one force we have in a downward direction. I would call it as F sorry, RFP you can say. Then we have an upward force, that is NP. Then we have a rightward force, that is mu NP, because this slip will occur in this direction because of the force, and the motion is in this direction. Then frictional force mu NP will be in this direction. In this case, the slip will occur is in this direction, so mu NQ will be in this direction. Okay. So what we can say here is, let's calculate tan of theta. Tan of theta 1 will be equal to 12 by 5, and tan of theta 2 will be equal to 5 by 12. Let's keep it as it is. Now, summation of all the horizontal forces equal to 0 if you do here at this point is mu NP is equal to the horizontal component of FRP, which is, let's say, this angle is theta 1. So this is also theta 1. So reaction RFP cos of theta 1, summation of all vertical forces will give you NP, which is acting in a down upward direction, has to be equal to reaction FP sine of theta 1. So these are the two things. If you put NP here, what you will get? Let's call it as mu P. Mu P into NP is FRP sine of theta 1 is equal to FRFP. This is also RFP. Let me correct. Reaction. Okay, cos of theta 1. So basically, this will get cancelled. In simple words, mu P is equal to cos of cos by sine is cot of theta 1, that is pi by 12. Okay, keep it as it is. In the same way, we can say that mu q will also be equal to cot of theta 2. Similarly, mu q will be also equal to cot of theta 2, which is 12 by 5. Okay, and what they are asking us to calculate is the mu q by mu p. So it is 12 by 5 divided by 5 by 12, which is equal to 12 into 12 divided by 5 into 5, which is equal to 144 divided by 25, and that is equal to 5.8 approximately. Okay, so 5.8 is the correct answer in this case. They are not given the answer, but asking us to type 5.8 is the correct answer in this case. Okay, it is very natural to understand that why um, mu q is equal to cot of theta 2. We have already proved that mu 1 is equal to cot of theta 1. So the same analysis you perform, the directions will be similar more or less, and ultimately you will end up with a mu q also cot of theta 2. Okay, so there is, you can save your time and apply your logic or sense here to calculate the coefficient of friction at point Q. Coming towards the next question. Let's talk about it. This one is a cylindrical disc of mass m equal to 1 kg and the radius r is equal to 0.15 meter, was spinning at omega is equal to 5 radians per second when it was placed on a flat horizontal surface and released. Gravity is g, acting vertically downward direction. The coefficient of friction between the disk and the surface is a finite and positive. Disregarding any other dissipation except that due to the friction between the disk and the surface, the horizontal velocity of the center of the disk, when it starts rolling without slipping will be. So this horizontal velocity is what they are asking. Okay, this is what they are asking. What is the horizontal velocity of the disk when it starts rolling? Okay, let's try to solve this question. Couple of things we have to understand in this case. Let's start with the basics first. V is equal to U plus 8. Okay, let's talk about first the accelerations part. We know that force is equal to mass times acceleration. And similarly, torque is equal to I naught alpha. In case of normal force, basically simple force, we call it as F is equal to ma, and in case of torsional force, okay, basically torque, we call it as I naught alpha. So basically I naught in this case is mr square by 2 into alpha, because it's a cylindrical disk. Now let's talk about the kinematics part here. That is V is equal to U plus AT. We know. Also, using this formula, we know that initially, when the disk touches the ground, initial velocity will be 0. So, um, what you can write here is the V is equal to acceleration times t, which is mf by m times t. So from this, the t can be written as Vm by f. Let's keep it aside. In terms of rotational, V is equal to U plus AT can be written as omega is equal to omega naught alpha t, omega naught minus alpha t. Okay. This is because, yeah, this is a retardation, so we can write it like this. Omega is what? Omega is equal to V by R. What they have given here, that was spinning at a 5 radian per second. So initial omega they have given to us, that is 5 minus alpha. How to find the alpha? That is the main point now. Torque. Torque is equal to what? Force into the radius. So I would say F into R. So from this, alpha can be written as 2F by mr. So minus 2F by mr is our alpha, and T is Vm by F. Okay. So here FF gets cancelled, MM gets cancelled. V by R is equal to 5 minus 2V by R. 2V by R comes this side, it will become 3V by R is equal to 5. This implies V is equal to 5R by 3. 5 into R is given as 0.1 by 15 divided by 3. We'll end up with 0.25 meter per second is the final answer in this case. They are not given the options. Up to 2 decimal places they are asking. So 0.25 is the correct answer in this case. What we have did is here we have used the basics. V is equal to U plus AT formula, and we have written it in the form of omega. Omega is equal to omega naught minus alpha t, because yeah, the body is sliding as well as rotating, and yeah, we have calculated alpha by means of the Newton's law of motion. Coming towards the next question. Yeah, this is the last question of this paper. This is from the theory of machines, gear trains topic. Let's try to understand it. Schematic of an epicyclic gear train is shown in the figure. We have a sun gear 1 and the planet gear 2 and the external ring gear 3. Okay, the ring gear is internal. Okay, sorry, let me correct. Gear number 1 and gear number 2 are external. However, gear number 3 is internal. Gear 3 is basically the ring gear. Gear 1, gear 3, and arm OP are pivoted at O. So this particular gear and arm is pivoted here. The gear 2 is carried by the arm OP via the pivot at point P. And it is enmeshed with the both two gears, internal as well as the external gear. Gear 2 has 20 teeth. Gear 3 has 80 teeth. Gear 1, they have not given how many teeth are there. If gear 1 is kept fixed, okay. So basically they are fixing this gear. Fixing this gear means 0 RPM. And gear 3 rotates basically at 900 RPM counterclockwise direction like this. The magnitude of angular velocity of arm OP is. So basically, N arm is what they are asking us. At this stage, we know that what is this diameter? We can say the overall, or let's say the, I would say the radius of gear 3, I would say, is equal to radius of gear 3 is equal to radius of gear 1 plus diameter of gear 2. So that is 2 times radius of gear 2. Okay. R3 is what? Module is equal to what? Module is equal to d by t. So diameter is equal to module into t. Radius is equal to what? Module into t by 2. So it's a mt3 by 2 is equal to mt1 by 2 plus 2 times mt2 by 2. M gets cancelled here. 2 gets cancelled here. So I would say T1 is equal to T3 minus 2 times T2. T3 is 80, T2 is 20. So 2 times 20 is 40. So this is 40. So T1 is equal to 40 teeth. Let me write it here. Okay, T1 is equal to 40 teeth. Next part is the by using relative velocity method, I can say N1 minus Nr divided by N3 minus Nr has to be equal to minus T2 by T1 into, directly we can write T3 by minus T3 by T1, but just for simplicity I'm writing like this, and these two terms will cancel out, and at the next step you can say it as minus T3 by T1. Now we know that N1 is 0 because the sun gear is fixed, they have mentioned. N-arm is we are supposed to calculate. N3 is 900 RPM in the counterclockwise direction. So let's consider counterclockwise as negative. Is negative is our assumption. So minus 900 minus N-arm is equal to minus 80 by T1 is 40. So minus N-arm divided by okay, if you take minus from the denominator, it will cancel out with the first, so it will be 900 plus N-arm is equal to minus 2. So I can say that if you simplify it further, what you will get, N-arm is equal to minus 2 into 900. Okay, minus 2 into N-arm. So basically this 2 N-arm, it comes here, it will become 3 N-arm. And that will become minus 1800. So N-arm will be minus 600. Minus 600. Negative indicates the counterclockwise, we say. Okay, so it's a counterclockwise is the direction, and magnitude is 600 RPM. Let's see what is the option here. They are not given option. They are clearly asking us to write the integer. So 600 is the answer in this case. They are not asking us to say whether it's a clockwise or counterclockwise. So the correct answer is 600 in this case. So yeah, it was very easy question from the gear trains topic. So that's all from this paper. Thank you all for watching this video. Bye.